So the feature request of making it so that as an object moves vertically up the screen, they appear to scale in size, so it seems like there's kind of 3D or perspective occurring there. It's a nice effect. And done subtly, it can be really effective and give you some really cool end results. And the key thing that we're working with here is we know our or our Y position, and we know how that relates to the overall height of the stage. That's a fractional relationship. So if my registration point gets all the way down here, my position is 100% of the height of the stage. If I am here, my Y position is 0% of the height of the stage. So what we can really do is we can play with that number, recognizing that X scale and Y scale are just simply values from 0 to 1, or percentages, the same way that my position here is a percentage of the total height of the stage. We can start to change the scale. So, nope, I mean to pull that off. Let's put it back on. Click here. So really, what I'm doing is I can now do a calculation of pumpkin.scale x is equal to, and as a basic value here, I could say it's equal to, and 1 is 100%, and 0 is 0% scale, so it will shrink it down. So if I'm at 0.5, that's 50%. So if I take my pumpkin.y and divide that by stage.stage height, that's going to scale it on the x value. And I can also change my y value. Now this is probably going to be too dramatic of a change because I'm going to shrink down to nothing at the top of the screen and really big at the bottom. So we're going to have to temper this number a little bit, but we can use this as proof of concept that it is indeed working. So with that, now I can move down, so now I'm at 100%, and it moves back in space. So I start to create that illusion, but if I go all the way up, we can see itty bitty tiny thing off in the distance. So we're going to have to find a middle value that's going to work with that. And now to do that, it's really just a matter of figuring out what is that math relationship. So the magic of the math, pumpkin divided by the height of the stage gives me a number 0 to 1, divide that by 2, from 0 to 0.5. I add to it 0.5. That gives me a range of 0.5 to 1 for my possible scale. So we can now see there's 1, there's 0.5. So now I've taken care of adjusting the scaling based on Y position of my object on screen. All right, so I have a big X that I'm going to use, and we'll be doing collision detection. We'll do the box-based collision just to keep it simple. And then this will be big X. Okay. Now, big X needs something to happen, so once it's here, I want to be able to go. I mean, there's other options where when I collide with this X, if it's big X1, then I could add to my stage a new movie clip of something playing, and then when that thing's done playing, I can remove that from the screen and remove the X. So or I can add extra frames to the X here as part of it, so that's another possibility that I could do. I'm going to favor that method right now just to keep things so we have fewer timelines at work, just because we're not really into the add and remove child thing yet. We'll be getting there in the coming weeks. So if there is my X, turn on onion skinning so I can see, add in a frame. I don't want red anymore. Let's get green. All right, a little basic. Basic shape going on here. And I'm going to add one frame of emptiness at the end so I don't have to worry too much about deleting it. Okay. So now I have my big X on stage. And it's going to be a matter of figuring out how to lock things down. We'll use a timer object so that when the collision occurs, the timer object fires off and it traps him there. But we could also, if we didn't use a timer object, we could trap him there while that object finishes playing, and then he can move again. So we could kind of go either way on that one in this instance. But we'll work with the timer object first and then look at the other method as well. Knowing that that's 12 frames, it's only about a second worth of play, but we'll make that happen. So at this point, I need to put in a check collisions function. I could do it as part of my loop, but I prefer to have it in its own function. I just find that makes things cleaner. And at this point, so if pumpkin.hit test object big X, at that point now we need something to happen. And what I can do is actually I'll just keep my naming consistent. Collision timer. So I'm going to trap him when it happens. He has to stay there for 2 seconds. And he can't move, keyboard input will be lost, etc. Well, I've created an object, collision timer, I told it to start. The problem is I haven't made that object yet, so I will need to go back up and create that object. Collision timer, object timer. Go into my setup and define it. Equals new timer. The delay, I'm going to stay at 1000 because it's 1 second, and we will have it repeat for 2 seconds. Knowing this is a super fast animation, that makes sense just to go that long. Well, I have to add some listeners. I did remember, though, that big X, I need to tell it to stop so it doesn't start playing. So when the movie starts, I want it to stay on the X and not to go through its animated cycle. So I need to provide that information to it. I could put a stop in that movie clip, but I really prefer to have all of my code out of the objects. I don't want the code inside the object. So I have my collision timer, and now we can tell that collision timer add event listener, and what we really care about is the timer complete event. Oh, I hit return I think too many times there. Now I'll keep the naming the same as before, timer done. Now we just need to define that. So when the timer is done, I will say allowed to move equals true. Allowed to move is a Boolean that I'm going to set. So when that collision occurs, I tell the timer to start, and I can say move equals false. Booleans are a really nice way. They're switches to allow or disallow certain things to happen. Movement, keyboard input, all these things that we can start wrapping it. So that's a Boolean. Now, doing coding where you're kind of building it on the fly, you didn't come up with a whole plan and you knew all the pieces ahead of time where we had a feature. Now I'm adding a new feature. Now I'm adding a new feature. Sometimes you add the feature, then you'll go back and go, okay, I guess now I need to put that Boolean in. So I'd say var allowed to move type Boolean equals false or true. So we're allowed to move. When I collide, I can't move. When the timer's done, I can move again. Now what we need to do is to wrap, either wrap all of this or we just add further conditionals. So we could wrap all of the movement inside a conditional that says, hey, are you allowed to move? If so, then you can do this stuff. So if allowed to move is true, I can do what's in the loop. Or I could, in each one of these, I could go through. So if I pressed up, so if I'm less than 0 and up and allowed to move, and I could say allowed to move or allowed to move equals true. And I could add that to each one of these. I could do that. In this instance, I really like wrapping it all inside an if because it makes sense that I don't want to do any of this if I'm not being allowed to move. I shouldn't check for collisions. I shouldn't allow it to even inquire whether it can do anything. So it says if allowed to move. So if I can, then I can do the rest and then use the auto formatting, cleans it up. So if allowed to move, oh shoot, forgot my preferences are off here. So if allowed to move is true, then I check to see, hey, am I within the parameters of where I'm allowed to move? Do my movement, do my scales, check for collisions. If I collide, I start my timer. I say allowed to move is false, which means I won't be able to move anymore, so it will ignore my input. And finally, I need to, well, we'll take a look and see. Okay, I'm here, move over. And now I'm stuck, pushing keys, and, oh, stuck again. Oh, stuck. So it's freezing it for 2 seconds. I think what we could do in there so we have a visual clue of what's going on. Then when we start that, we could also, when we're when the timer's done, simply say trace OK. Now it traces out. Now I can move again. And I'm holding the key and it's moving. It moves, it freezes for 2 seconds, it moves, it freezes. But it's not really freezing for 2 seconds anymore. What we also need to do is, once a timer goes, it's necessary to reset the timer, otherwise it keeps firing off and firing off and firing off. So it's required that we need to put a reset in as well. And I can just simply say collision timer dot reset, like that, and that resets it. So now locked. Now we're getting the true 2 seconds between each thing. But it's not telling my big X to play yet. So once we hit, at that point it would make sense to say big X dot play. Having a little issue going on there. So now what do I need to say? What do we need to have big X do? How does big X know when to stop? I could put a stop in its timeline, but again, I hate putting stops in other timelines. I want to keep it there. Can we listen for it being done? Flash likes to listen for things. So what I can say is big X dot add event listener, and this would be event dot enter frame big X done. I'm going to put it down here.
And you have to write that big X done, right?
And now I have to write my function big X done and E colon event. And now what big X is listening for is it's going to say if. Now we could say if big X, but we can also make a generalized reference. The object that registered this event listener, we can refer to it by E, because it's now E right here. This is the object that registered the event listener. Big X registered the event listener. The object of the event is E. So if we say E dot current frame is equal to E dot total frames. So if we find out if the current frame it's on is equal to its total number of frames, then we can say dot stop. Oh, and sometimes code completion gives you things you don't want. So now we can tell it to stop. Oh. So the error messages are, it's not E.currentFrame, it's E.target.currentFrame. So it's the target of this event. I had a little brain freeze there. The target of this event, big X, its current frame is equal to its total frames, and we can tell it to stop. So this E.target, I could have just written big X in that place. A reason why you might not want to do that, if you have 50 objects on screen, instead of having this referring to a function for one object, if this is generic X done, and if I have 50 objects, so generic X add event listener, event enter frame, generic X done, all 50 can call this one function that will check to see if they're done and then tell them to stop. So you could have one function for all 50 of your animations that you may put into your project. So I'm going to actually do that, and I will make a second animation like this. So we have generic X done. That means I need a second animation, and under collisions I will need to there, so we can check and just do that with that. So if pumpkin hit test, so we'll have big X, then I'll have a little x. Little x and little x. Now if we're having a big X, we'll need a little x here. And the only thing that's missing now is my little x. Put that there. Little x. Make it smaller so it is indeed little x. So we have little x, big X. Little x and big X both stop. During collisions, if I run into big X, it does this. If I run into little x, it does this. And then both of them will call this generic done function. The more you can use one function with multiple objects, the less coding you have to do, the less errors you're going to have, and the happier you will be. So we'll go hit little x. I can move, and big X. So now we've created our own kind of version similar to, oh, and that's the limit. I forgot there's limits. I can only go within 100 pixels of the edge on that and 100 of that edge. I forgot. This movement code had limits built into it.